Hi folks, I would like for you to start out by trying the warm-up. So the first one is write a rule for the pattern. The next one is find the sum. So very similar to what we've been practicing the last few days. If you need to join my office hours, please feel free to do that. We have our little assessment on Thursday before we leave for break. So this is the last new material that you're going to see before then. So please check in. We're just going to practice on Wednesday. I'm going to have you kind of review on your own. The assessment is pretty short, so it's not going to take you very long, but it should kind of showcase everything you guys have done. So try those out. Pause the video. When you're done, I will have the answers. All right, folks, hopefully you were able to figure out the first question. It can be a little bit tough because it's not an arithmetic sequence. It's not what we're used to doing the last few days. However, what you should always do if you're stuck on how to figure out the sequence is write the term numbers. So 1, 2, 3, and what you should probably see is, oh, this is 1 squared. This is 2 squared. This is 3 squared. So you're taking, if you write it as a sub n, you're taking n and squaring it, the term number, okay? To find the sum on the next one, remember you have to plug in. What's weird is they don't give you n here. It should be an n equals 2. You may have noticed that. If you did, you may have not completed it, which is totally understandable, but that should be n equals 2 to 5, and you're going from 2n to over n minus, or 1 minus n. So you have to plug in 2, add, remember because the e means sum, 2 times 3 over 1 minus 3. That was a 2, by the way. 2 times 4 over 1 minus 4. 2 times 5 over 1 minus 5. And those are the only terms you have to plug in. And when you put that all in, you get either 73 over 6 if you use a fraction, or about 12.2-ish, okay? Just recognize that this pattern is neither geometric nor arithmetic. What we're learning about today is geometric sequence and series is when you multiply each term by something to get to the next term, which is not true. Arithmetic was you add or subtract, okay? So the big difference with a geometric sequence is you multiply to get to the next term. The easiest way to figure out what you're multiplying by is to divide your second term by your first. So you can probably see I'm multiplying by 2 here, multiplying by 2, but say it wasn't that obvious. Instead, if you do 4 over 2, that's 2. If you do 8 over 4, that's 2. So that's your common ratio, okay? Same thing with the next one. If you divide 36 by 12, again, it's 3. 108 divided by 36 is also 3. So your R, or your ratio, very similar to a difference, but it's what you multiply or divide by, is times 3. One thing to notice here is, say your ratio is fractions. You want to do 1/9 divided by negative 1/3, which is like times negative 3. So this ends up being your ratio is negative 1/3 because you're multiplying by that number to get to the next. Okay, so what I want you to do for this is, all I want you to do for these next few is try to find R, find your common ratio, okay? And then we'll actually find the rule for the next few together. So just find R, pause the video, hopefully you'll get that far, and then we'll actually find the pattern. Okay, folks, hopefully you got R equals 3, 2, and negative 1/4. One thing you want to check is that it works across the first few. So times 3 works, times 3 works, times 3 works. Times 2, times 2, times 2, we're good. Times negative 1/4, times negative 1/4, times negative 1/4, okay? We're gonna actually write the rule in the next page, so this will be the intro for this, but we can actually find a formula. Okay, so we're gonna get into the nth term, or this, or sometimes they call it the rule. The explicit formula is another way to say it. There's lots of different ways. But one thing to point out is you already now know what R is. So R is your ratio. You know what A1 is. That's still your first term. Okay, and then N is still whatever term number they give you. Okay, if you're writing a rule though, you don't actually have to plug in anything for N. So just to start off, we're going to write the first 5 terms of a sequence. So we're going to figure out, if we know that A1 is 3, how could you figure out what your next two terms are? So what's nice is you don't actually have to show work for these. You could just say your first term is 3. If your ratio is 2, that means my next term is 6, and then 12, and then 24, and then 48. Because you're just doubling, that's what that R means, you're doubling each of those terms. Okay, I want you to try the next one. Now notice your ratio is 4. All right, hopefully you guys figured out the pattern. Was for the second term, or first term was 2, and then you multiply by 4 every time. So that's why you get these terms. We're going to use now the formula to help us figure out the 15th term. The 15th term is a lot more annoying to find by hand unless you have the formula written out. So I just want to remind you that if you want to find the nth term, this is how you figure it out. Plug in the values you're given. So if we're looking for a sub 15, and the first term is a sub 1 equals 20, we can just plug in what we're given. The ratio is 1.05. So what that looks like is if you plug in A1, which is 20, the ratio is 1.05, and then we can plug in 15 for n. And then you can plug that straight into your graphing calculator, so we get 20 times 1.05 to the 14th. You can round and say it's approximately 39.6. Okay, so that would be your 15th term. I want you to try the same thing, but find the 12th term. Use the formula, whose first term is 14, and the common ratio is 1.2. All right, guys, hopefully you got 104.02. You had to do 14 times 1.2 to the 11th, because that's 12 minus 1. All righty, we are moving on. So now they want the formula for the nth term, and then use that formula to find the 9th term of the sequence. So this is a slightly different question because they're asking you to do two things. The first thing you have to do is figure out your common ratio. So what are you actually multiplying by? Again, if you need to, list out what you're given to. So A1 equals 5. Your ratio would be either 15 over 5, or some of us can see that that is automatically 3. Okay. So find your nth term first, which means don't plug in anything for n. Okay, your first term is 5. Your ratio is 3. You do need parentheses there because, remember, order of operations, you'd raise it to the n minus 1 first. Okay, and then now find your 9th term. Okay, notice that you can't do anything to simplify this. That's not possible. You can't multiply 5 times 3 because the 3 has a variable. Okay, but now you can plug in 9 for n. Okay, so you end up with 5 times 3 to the 8th. And your 9th term, crazy enough, would be 32,805. Think about why it's so big. Because if it's a geometric sequence, you keep multiplying by that same number, and it's by a pretty large ratio. There's 3. So, all right, the next one, find the 4th term, the 4th term is 125. The 10th term is 125 over 64. Find the 14th term. So what I want you to do first is just label what your terms are. So pause the video, label what you got, and then we'll go from there. All right, guys, so notice that this is a little different because they're given the 4th term and the 10th term. You're not even given the common ratio, so you actually need to calculate that first. This is very similar to arithmetic sequences where actually you can plug in information that's not in the original. Just remember the original formula is a sub n equals a sub 1 times r to the n minus 1. So notice these match, those match. So as long as you change both of them, you're good to go. So in our case, one thing I want to point out is that they say assume that the terms of the sequence are positive, because if they alternated between positive and negative, that means your ratio would be negative. So just keep that in mind. Okay, so instead of the first term, we're given the 4th. So I'm actually going to plug that in for A1 instead. But I'm also going to plug in A10 for n, because otherwise I have too many variables going on. One thing to also notice is I'm solving for r, because I don't know what that is yet. If I change the n, I have to change the n in the exponent. So now my n is a 10, which means it becomes 10 up here. Notice the 1 turned into a 4, so I have to subtract 4. So you're allowed to do this because you're changing both sides. And then I plug in what I know. A10 is 125 over 64. A4 is 125. That turns into the 6th power because you can subtract. And then you can just divide. So divide both sides by 125. Divide by 125, which cancels out that 125 on the top. So you get 1 over 64 equals r to the 6th. And then, how do you undo a 6th power? That's right, with the 6th root. So the 6th root you can actually go to, if you forget how to get here, it's, you would type in the number 6, go to math. Number 5 means any root, and that would be of 64. Okay, so that's 2. So r, if you didn't know what the 6th root of 64 was, r equals 1 over 2, because the 6th root of 1 is 1, the 6th root of 64 is 2. Okay, so your r equals 1/2. We're not quite done. I would actually write the nth term first, so you can actually still use your 4th term if you want to, or now that you know the ratio, you can actually go backwards and find your 1st term if you want to. So normally we'd be multiplying by 1/2, but instead, to go backwards, you can multiply by 2. So say you wanted to find the 1st term. You know your 4th is 125. Ratio is 1 over 2, which means we'd multiply by 1/2 to get to the 5th term. Or you could multiply by 2 to get your previous term instead, which if you think about it, if you multiply by 1/2 for each of these, you get the next term. So you could either use now the fact that A1 is 1,000, or you could keep the substitution of that A4 is 125. It's up to you. Either way, my nth term now is A sub n equals, if you want to use 1,000, you can do that, and our ratio is 1/2 times n minus 1, and now I could find a sub 14, because that's the term they want. Okay, either way, you're going to get the same answer, even if you plug in A4. I'll show you how to do that in a second. But you should get that A14, if you keep it as a fraction, it's 125 over 1024. Or if it's a decimal, it's 0.12. This is a little bit better because it's more accurate. Now, if you instead just kept the 4th term, I'm going to do this off to the side in green so you can see it, but if you wanted to write your nth term by using the 4th term, you would just say it's really 125, because that's your 4th term, times your ratio to the n minus 4, because we used the 4th term instead of the 1st. So that would be your nth term. That's totally fine to do instead. And if you plug in 14, you get the same answer back. So either way, it'll work. Okay. Number 1 and 2 are very similar to the previous 2 that we did. So try both for me. Pause the video. And when you're done, I will have the work and answers for you. All right, guys. So for number 1, hopefully you got that your nth term was a sub n equals 4 times 5 to the n minus 1, because again, your 1st term is 4, your ratio is 5, and then you leave n alone if you're looking for the nth term. And then if you're looking for your 12th term, plug in 12 for all of the n's, and you get, whoa, big. Get 195,312,500. Geez, that's big. Okay. And then for number 2, they wanted the 8th term. If you need a little bit of work for that, just a reminder that the 2nd term was 6, and your 5th term was 81 over 4. So you have to solve for your ratio first. And then you can actually keep just going to the right if you want to, because 5 is not that far away from 8. Or if you plug it all in, once you figure out your ratio, you can do A5 equals A2 times r to the 5 minus 2. So that means 81 over 4 equals 6 times r to the 3 divide by 6 on both sides, cube root it. And that means you get r to the third equals 27 over 8, which means r, when you cube root both sides, you get 3 over 2. And then when you plug it back in, you can go straight, because I didn't ask for the nth term. If you want to go straight to plugging in 8, that's fine. You can still use the second term if you want as well for your first. So you could do 8 sub 8 equals, the second term is 6. Just be careful because now you know your ratio. So then this would be 8 minus 2 because you now are looking for your 8th term. So either way, this fraction is more exact, the 2187 over 32, but you can approximate it and say it's 68.34 as well. Alrighty guys, last section here is the sum of finite geometric sequences, and then we'll do infinite. So, slightly different formula. Again, you guys don't need to memorize any of these because you will have your notes in front of you. Just a reminder that this is the sum of a finite series, which means it should have an end to it. If you see the infinity sign up there, you can't use this same formula, okay? So just be careful. We're going to do this one together, but I want you to think about how this relates back to what we just did with arithmetic sequences. So I want you to be careful that your 12 is going to be your n in the formula. I'm not going to even define these because you already know what all of these things are. And then to figure out your a1 term, you plug in 1 for n. So it's 4 times 0.3 to the 1. Be careful, this is not exactly the same format as what we're used to. So you'd actually have 4 times 3 over 10, so it's really 12 tenths. You could also just do 4 times 0.3 in your calculator, which is 1.2. So if you prefer 1.2 instead, that works for me for your first term. And then now we just need r. What you probably notice is that r is right there for you, so it's 0.3, okay? You could always plug in your first term and second term and just see if you can figure out your ratio from those two if you prefer, but it's always going to be right there as well. Okay, so if we plug in for our formula, they want to find the sum of the first 12 terms by using this formula. A1 we said was 1.2. Make sure if it doesn't come out to a nice decimal though, you actually use the fraction because otherwise you're going to get a wrong answer. 1 minus 0.3 to the 12 over 1 minus 0.3. And then when you plug that all in, just be careful of parentheses there, but you should have 1.2 times parentheses 1 minus 0.3 to the 12th. If you need to do it separately, you're welcome to. And then you're going to divide by 1 minus 0.3. Close parentheses again. Okay? So you should end up with 1.71 is the approximation. Okay? And that's good enough for now. You are going to get some weird decimals in there. But just double check that you plugged in everything correctly if you did not get that answer. All right, I'm going to have you try this next one. Notice it's a slightly different format. Instead of having n's, they have i's. It's the same idea, but look at there, very similar to our formula. So what you'll notice is when you find your first term, it's going to be interesting. So try this one out. Find the sum of the first 10 terms, and you're good to go. All right, folks, hopefully you got approximately 2.67 when you plugged it all in. What's nice about this equation is your first term is actually right there, mostly because it's I minus 1 instead of just I. So if you tried to plug in 1 for I, you'll notice that turns into 0, and anything to 0 is 1, and then times 2. So you had this, basically, which this cancels, it turns into 1, so your first term is 2. Your ratio was 0.25, n was 10, and when you plug it all in, you get 2.67. If you had trouble with any of that, please feel free to join my office hours. I'm happy to help you out, especially because tomorrow you guys have your little quiz. But if you're having trouble with this, I'm sorry, not tomorrow, Thursday. You're having your little quiz. You have a little practice tonight with your textbook homework. I gave you all odds. We have one more little section to do, but the practice tomorrow, I'm not going to have you turn in. You're just going to see the answers for it. So please let me know if you're having trouble with it at all. I can, join a group separately if you need to ask me individual questions for a Google Meet. My Chromebook is broken, which is annoying, so I have to do a Google Meet through my phone. So I can't project everything that's on my screen, but I can just show you through my camera some things. So if you have questions, please ask. All right, last thing that we're gonna do is infinite series. Now, the reason you don't have an infinite series with an arithmetic sequence is because you literally approach a number over and over again. So it either equals infinity or negative infinity, which is the big difference. Here, what you'll notice is that you can find the sum of things that approach a number, but not if they're too big. So what I want to do is just give you an example. Okay, so if I have, let's do 2, 4, 8, and so on. Now, if I added those all together infinitely, and your ratio would be 2, what you would notice is that you just keep adding larger and larger and larger numbers. So this would be infinity. So what they say is that if your ratio, the absolute value, is greater than or equal to 1, it has no sum because it goes on forever. If your ratio is less than 1, aka a fraction, so let's do instead 2, and then let's multiply by a half. So 1, a half, a quarter. What you should notice is that these numbers are getting smaller and smaller and smaller. So they approach 0, which is kind of strange. So what ends up happening is you actually get basically only the sum of the first few digits. This formula nicely does that for you. So the first thing you want to do is check, first of all, is that ratio less than 1? Is it a fraction? Okay. 1.2 doesn't count because that's greater than 1. This one works. Okay. So we want to find our first term if we want to find the infinite sum. So our first term in this case would be 4 times 0.6 to the 1. So it's 4 times 0.6, which is 2.4. Okay, that's your first term. So that we would plug that in. 2.4 over 1 minus your ratio. And your ratio here is 0.6. So the formula is actually pretty straightforward. You just have to be careful and only use it when your ratio is going to be between 0 and 1, basically. What you do is put that in your graphing calculator. Just be careful of order of operations. Weirdly enough, you get 6, which is so strange. So notice for this sequence, it would probably be close to 4 because you're adding 2 plus 1 plus a bunch of other small numbers. So that's what ends up happening with infinite series. For the next one, you have to be careful because they don't actually give you the formula. This tells you that it's infinite, though. So what we want to do is plug in for the numbers that are going to be happening here. So let's do, our first term is 3. So we'd want to go from, we already have our sequence, so we don't even have to worry about that. I lied. We don't have to figure out a formula at all. Just plug in the numbers, which is great. Okay, so if you plug in, you get S equals, the first term is 3, okay? And then I can do 1 minus my ratio. So I just need my ratio here, okay? Remember, you have to figure out what you're multiplying by. So if you can't see it very clearly, divide your second term by your first. And that's the same thing as thinking about what am I multiplying by. So you end up with 1/10 or 0.1. So if you divide 3 by 1 minus 0.1, you actually end up with 3 1/3. Or, to make your life easier, if you want to do 10/3, that's probably a little bit easier to work with. Okay, so I'm going to have you try the 2 on the bottom. See if you can figure out what they are separately. Feel free to pause it and go back if you need to look back at how to do the previous ones, but try both of these And when you're done, I will have the answers. All right, guys, check out the answers. They are 10 and then 6.25. So I wrote the work down for both of these. Remember, for A1, you have to actually solve for it if they have a slightly different version of the formula there. It's always a good idea just to make sure you're doing it correctly by plugging in 1 for your first term. It kind of helps you verify that you're good to go. And then for letter B, you had to figure out your ratio. Oh, it's 1/5 because you could just do your second term divided by your first. It works the same as if you did 0.2 divided by 1, so you get the same answer. It's because 1/5 is 0.2. Your first term was 5, so you end up with 6.25 when you divide that out. Have a wonderful rest of your day, folks. If I do not see you in my office hours, have a wonderful vacation. We're going to just do, again, a quick little quiz of 8.1 to 8.3 on Thursday. Tomorrow it's just going to be some 8.3 practice. No need to submit anything tomorrow. I'm going to have the answer key posted as well, so you can just check how you're doing. But please, please, please make sure to check in before you take your quiz if you are struggling with anything. All right, enjoy the rest of your day.